Well, hello everybody. Welcome back. Oh my goodness gracious. Sorry that took a while, and sorry there's a bunch of dead air there for a while, like silence. I did not realize that my Spotify was just not playing for some reason. Played that one song and then it just stopped. I don't know what caused that. But we're here now. We're here now, so we're good. We're good. We Gucci. Let me just do this real quick. And we should, keyword here being should, be good to go. Give me one moment. Let me do this real quick. Perfect. Okay. Alrighty. Let's move this over here. This over here especially. Alright. Close out of you. And we should be good to go. Hello everybody. I clicked the wrong thing. There we go. So, yes. Last time we did this stuff, a big confusion was at play, but it was not to deter us. We are working towards our dream here, so things such as being fucking confused as hell about why they're bringing shit up that we've never once told us about beforehand. I think we're gonna make it. I think we're gonna make it. I might start doing the old what we do in Kingdom Blender, where I just branch off and do my own thing once I got. Excuse me. It's generally speaking the just. That way I can experiment and kind of figure things out in my own sort of way, you know. But yeah. Well, to be fair, let's go ahead and finish at least the 2D game thing. I think we might go ahead and do 3D too, but you know, once we did the getting started stuff done, even if we're a little confused, we can figure it out. I'm confident we can. We should be able to. Okay. Alrighty. Let's see here. Where were we last? Open this up real quick. Launch you. Alright, this is what we were on last time. There we go. Ready. Okay. Now it's creating the enemy. Now it's time to make the enemies our player will have to dodge. The behavior will not be very complex. The mobs will spawn randomly at the edge of the screen. Choose a random direction and move in a straight line. We create a mob scene, which we can then instance to create any number of independent mobs in the game. Node setup. Click scene, new scene for the top menu, and add the following nodes. Root your body 2D, named mob, a 2D sprite, collider shape 2D, visible on screen notifier 2D. Okie dokie. Scene. let's fix this real quick. There we go. I assume this is the same as doing this. Yeah, pretty much. Okay. Add this. Where's your body 2D? Rename it to mob. There we go. Let me move this out of the way real quick. That. Yeah, we're good. Okay, Bob is, where did we, okay. Here, there we go. And Sprite 2D. Okay. Use way. Shade 2D. As well as fire. Image at 2D space at the text leader, it is visible on the screen. 2D space that, when visible on screen, enables a target node. Gotcha. Alright. Don't forget to set the children so that they can be selected. Like you do with the player scene. This is done by selecting Parent Ultraviolet 2D in the scene dock. In the scene tree dock, then using the group button at the top of the 2D editor or pressing Ctrl+G. Ready? Select the mob node. It says gravity scale properties in the Divided 2D section of the inspector to 0. Okay. It's set to 0. To prevent the mob from falling downwards. What happens if I just do... I should probably get this thing official. And I do the sprite frames, there we go. Clicking on this. Okay. If I go back to this. Let's see how I do this. I think it's just gonna go downwards, right? Okay, first of all, save it as mod.tscn. Oh, it does! Huh. That's actually pretty crazy. One moment. Hold on. Oh, jeez. It got really itchy nowhere all of a sudden. Anyways, back to this. Jeez. I guess it's because it's a physics property. I suppose. know. Interesting though. So we I don't know if this is showing. If I hit Alt, my Alt key's broken, by the way. This thing working? Come on. If I hit Alt, it's just a down arrow. Oh wait, it's the right and down arrows. Okay. I was like, is that just showing gravity? That's weird. But no, it's because yeah, it's the things that show the directions. Excuse me. In addition, under the collision object 2D, the action just beneath the rigid body 2D section, expand the collision group and uncheck the one inside the mask property. This will ensure the models do not collide with each other. Okie dokie. Which one was it? Vision. There it is. Set up the animated sprite 2D like you did for the player. This time we have 3 animations: fly, swim, and walk. There are 2 images for each animation in the art folder. I think I did flying. It's right here. Fly. There's such weirdly different fucking animations. Also different enemy types. The animation speed property has to be set for each individual animation. Adjusted at 3 for all 3 animations. Okay. There we go. Use the play animation buttons on the right of the animations to preview your animations. That's pretty neat. Hell yeah. Okay. We'll select one of these animations randomly so that the mob will have some variety. Okay. Gotcha, that's why. Like the player images, these mob images need to be scaled down. So that the animated start 2D scale to roughly 0.75. Oh, hold on. Animated start 2D scale property. Okay. Scale 0. Got it. Did both, right? There we go. as in the player's scene, add a Castle 2D for the collision to align the shape with the image. You'll need to set the rotation property to 90 under transform the inspector. Gotcha. Okay, rotation transform to 90. Huh. I'll give myself a little bit of leeway here. Oh no, this is a hardcore game. What am I doing? So no leeway ever. Absolutely not. That make look this. No. Just kidding. So like that. And like that. There we are. Well, like this. Now let's look at the rest of the script in underscore ready. We play the animation and really choose animation types. Okay. Equals array. Get animation names. Is that a built-in thing? I'm curious. Search. Find. Get. There's no match for this at all. This is like the dogs, right? Chin. There we go. Returns an array containing the names associated to each animation. Values are placed in alphabetical order. Okay. That's all I wanted to know. Let's see here. So I can cause this to make an array. Maybe that's just screwed around a little bit. There. All types. Types. There's an array. Let's write 2D. Dot frame frames. Dot get animation names. Okay, now +sign animates for 2D dot shen dot equals mod types dot pick random. That's a built-in function. +sign start 2D dot play. Okay. First, so we get the list of animation names from the animated 2D sprite frames property. There's an array containing all 3 animation names. Walk, swim, fly. So I assume this just grabs from the child. Oh yeah, everybody knows. Just sort of get node, I don't know. So the $$ syntax is used to get a specific node. It's exactly the same as get node, except it saves you a couple of keystrokes. Okay, sick. You would want to always use it instead of get node. Gotcha. Curious though, how would I do get node if I ever wanted to? Oh, get node, and in parentheses it's path to, okay, and then it's how you get to that node. Okay, position. So it's just all right. I assume I somewhat understand that a bit better now. It's not even necessarily a child node, it's just a node. There's a D node. I would assume you'd ever really use more than one node in a single thing. No, wait, that's wrong. You have enemy or something that has multiple collision shapes. You'd have multiple of those. I suppose. Hey, let's get back to this. This is all stuff we figure out in the moment and slowly figure out as we go. We learn the moment, figure out as we go. Let's get the rest of the script in ready. we play the animation and we choose one of the 3 animation types. Gotcha. First we get the list of animation names. This animated sprite 2D sprite underscore frames property. This returns an array containing all 3 animation names: walk, swim, fly. In GDScript code, we use the array.pickRandom method to select one of these animation names at random. Meanwhile, in the C# code, we pick a random number between 0 and 2. To select one of these names from the list, I'm going to see from 0 and 2 to select one of these names from the list. I'm going to see start at 0. The expression gd.randy parentheses %n selects a random integer between 0 and n minus 1. What? Finally we can call play to start playing the chosen animation. Last piece. Expect the mobs to delete themselves when they leave the screen. Connect the screen exit signal on the visible screen of our 2D node to the mob and add this code. Sick. Q free. Okay. Free the queue of this thing's existence. This completes the mob scene. With the player and enemies ready, in the next part we'll bring them together in a new scene. We'll make enemies spawn randomly around the game board. Move forward, turning our project into a playable game. Alright. Okay. The main game scene. Now it's time to bring everything we did together into a playable game scene. I created a new scene and add a node named main. What's the day? It's Wednesday. Okay, so sorry, I got distracted because I was just thinking about something. Friday should be our last day programming until we go back to playing some more Spyro. Because I don't think I'm not gonna be doing this tomorrow. Create a new scene. Let me get out of this. There we go. Imagine that's a both of them. All right. Now it's time to bring everything we did together into a playable game scene. Create a new scene and add a node named main, because we are using a node instead of node 2D is because this node will be a container for handling game logic. It does not require 2D functionality itself. Okie dokie. Click the instance button. First it by handling icon and select your player.tscn. Hold on 1 second. I have to do something real quick. I just realized something's off. Oh, hold on. Makes sense why that didn't work. There we are. Sorry about that. I realized I hadn't sent out to my friends that I was live, and I had also forgotten to well, I didn't forget. I realized that my Discord just locked me out, so I had to log back in real quick. So anyways, sorry about that. Alright, we're back to it. Yeah. With the instance button, so actually go and select your stage player.tscn. Okay. Would you piss off? I disable that where it's like popping up with the overlay. Disability maybe? Game overlay, there we go. There we go. Those are still trying to pop up now. Did together in a playable game scene. Yeah, I read all that. I need to add the player.tscn to this though. Okay. Now the following nodes as children of main, and then as follows: timer, a mod timer, timer, and a score timer, timer named start timer to give a delay for starting. Child node. Oh yeah, timer. Go. And marker 2D. Hey. Timer. Let me that score timer start timer and start precision. Start timer start position. Ready? Set the wait time property of each timer does as follows. Values are in seconds. All timer, score timer, start timer. The only two I have to change, I think. All timer, score timer, start timer. Oh, 1, 2. Okay. In addition, set the one-shot property of start timer to on. Okay. And set position of the start position node to 240, 450. Uh, 240, 450, is that what it said? Yep. Right there. Got it. Spawning mobs. The main node will be spawning new mobs, and we want them to appear at a random location on the edge of the screen. The main node in the scene dock, a child path to the code node. Goodness gracious. We got the main node and the scene dock. I think I figured out why you're yawning so much. I'll tell you in a second. Hold on. The main node in the scene dock, and add path CD, the main bot path. When you select path 2D, you'll see some new buttons at the top of the editor. Okay, I'll do that in a second. Back to what I was about to say. I think the reason why I'm yawning so much is like it's not like hot, but it's like warming my like mask and everything. Because like I'm breathing in here, it's kind of like insulated. And I think it's just that warmth making me tired. I think that's what's causing it to happen. Like, what's the matter? This is I'm fine. It's just when I'm in it, I get like kind of sleepy, I guess. I don't like feel like sleepy, but you know, weird. Okay, back to what we're doing. When you select path 2D, you will see some new buttons at the top of the editor. Okie dokie. Select the middle one, add point, and draw the path by clicking to add the points at the corners shown. To have the point snap to the grid, make sure use grid snap and use smart snap are both enabled. These options could be found on the left of the lock button icon. Bring us a magnet next to some dots and intersecting lines respectively. Okay. There we go. Use. Spawn. Order. Or else your mouse will spawn pointing outwards instead of inwards. That's weird. After placing 0.4 in the edge, click close curve button and your curve will be complete. hell yeah. Now that the path is defined, add a path follow to the node as a child of mob path, name it mob spawn location. Right? Yeah. Mob spawn location. Just don't automatically rotate and follow the path as it moves. So you can use it to select a random position and prevent. So automatically rotate and follow the path as it moves. So we use it to select a random position and the direction along the path. Machine should look like this. Yeah, perfect. Main script. Add a script to main at the top of the script. We use export a variable mob scene. Package scene to allow us to choose the mob scene we want to instance. Go to the main node. Well, I do various one too. Go to the main node, and you'll see the mob scene property, and then searcher under main.gd. You can assign this property value in two ways. File system doc. The mob scene property. Click the down arrow next to empty and choose load. Select a mob TS yet. Where's load. It's mod.tc, not mod.gd. Okay. Next, select the instance of the player under the main node in the scene doc and access the node doc on the sidebar. Make sure to have the signals tab selected in the node doc. On a minute again. Sorry, it's just what's the one with? I'm gonna get itchy. Let's go on with that. Go back to normal. Set node doc on the sidebar. Make sure you have the signals tab selected in the node doc. You see a list of signals for the player node. double click the hit signal in the list or right click and select connect. This will open the signal connection dialog. We want to make a new function named game over, which will handle what needs to happen when a ends. Type game over in the receiver method box at the bottom of the signal connection dialog and click connect. You're ready to have the hit signal in from player and handled in the main script. Apply code to the new function as well as a new game function that will set everything up for a new game. Okie dokie. Don't pretend like I understood any of that. Game over connect. Okay. Yeah, okay, you're ready to push in. Okay, function, game over. Or timer.stop, about timer.stop. Score timer dot stop. Of timer dot stop. Cut. Funk. New game. Score 0. Player dot start. Start position. Position. $sign start arrow dot start. There we go. Now connect the timeout signal of each timer node, start timer, score timer, and mod timer. The main script. For each of these, the 3 items. For each of the 3 timers, select the timer in the scene dock. Open the signals tab of the node dock and double click the timeout signals at the list. So open a new signal connection dialog box. Open a new signal connection dialog. The default setting in the dialog should be fine. Just select connect to create a new signal connection. Once all 3 timers have been set up, you should be able to see each timer has a signal connection for their respective timeout. It will show you in green within their respective signals tab. Excuse me. Alright, you're the boss. That's weird. It's like it's smart. It knows like what I'm trying to say. Because even though there's no space here, it knows there is. It's insane. On timer timeouts, on score timeout, on start timer timeout. Now I define for each of these timers. Now we define how each of these timers operate by adding the code below. This start timer will only start the other two timers, and the score timer will convert the score by 1. Okay. Score plus equal to 1. Start timer timeout. $sign or timer dot start. Score timer start. And on mob timer timeout, we'll create a mob instance picking random starting location along the path 2D and set the mob in motion. The path follows 2D. Then will automatically rotate as it follows the path. So we use that to select the mob's direction as well as its position. When we spawn a mob, I'll pick a random value between 150 and 250 for how fast each mob will move. It would be boring if they were all moving at the same speed. Note that a new instance as is seen using add child. So you may it's the CDC add child. Okay. Where a mob equals mobs. Scene dot instantiate. Oh, good lord. Area full mob equals. Wait, I'll spawn a location. Okay. Small path. Oh yeah, here we go. Here we are. Mob spawn location dot progress ratio equals rand f. Progress ratio equals and F. What the fuck is progress ratio? Ratio, set progress ratio, get progress. So this is along the path as a number in the range of 0.0 for the first mix to 1.0 for the last. This is just another way of expressing the progress within the path. As the offset supplied is multiplied internally by the path's length. It can be set or only at the path follow 2D is the GLW path 2D, which is part of the scene tree, and that this path 2D has a curve 2D with a non-zero length. Otherwise, trying to set this field, it will print an error, and getting this field will return 0.0. Gotcha. Let's see here. Bob dot position equal to mob spawner location dot gen. So this one right here passes a random place along the path we created in order to put at a random spot around that circle we made. As you see here, this is just like one big line, so the 0, 0 is here and 1.0 is here, right? 0, 1.0. So it's anywhere between here you can put it. Alright, that just grabs the random value and puts and gives it to it for not only for it to make that spawn location, but to make the mob position that the mob spawner location's position. So that's a smart way of doing that. Set the mob's direction perpendicular to the path's direction. I don't really get what this means. I don't know why we're using pi here. Pi divided by 2. But alright. Well, 2 mob spawner location dot rotation is a spawn or spawner? Oh shit. Okay, I guess my brain was just too Minecraft filled. So I typed in mob spawner instead. Oh well, it's staying. It's not like it matters anyways. Rotation plus pi by 2. What the hell are you screaming at me about? We'll worry about that later. Stretch plus equals and F range minus pi divided by 4 or negative pi divided by 4 and pi by 4. Amazing. Mob rotation equal to direction. And where we define direction, similar to its location. This adds variability on the direction it does. Okay, adds some radius to the direction, yeah. Choose the velocity for the mob. Variable velocity equals vector 2. I'm sorry, I'm a little out of it right now. Damn, I've already been going on that long? Hold on, let me check this. Good God. I didn't realize it was already almost an hour and a half into it. Alright. Oh. Holy moly. Well. Not bad. Vision equals direction. Variable velocity equals. Okay. It's not. 2. And F range 150 250 0 dot 0. Mob dot linear velocity is equal to velocity dot rotated direction. Solve them all by adding it to the main scene. Add child up. Wow, that's a lot. I don't even get into some of that. So I even barely understand what's happening with this sometimes. I wish they'd explain why we use pi here a bit better. I'm curious to understand as to like what's causing it to go in the correct direction. You know, pretty sure it doesn't go in the wrong direction. Why pi? Oh, look at the devil. Why pi? In functions requiring angles, Godot uses radians, not degrees. Pi represents a half turn in radians by 3.1415. And there's also tau, which is equal to 2 times pi. If you're more comfortable working with degrees, you'll need to use the deg to rad and rad to deg function to convert between the two. Okay. Awesome. That didn't actually answer my question. Let's just the scene to make sure everything is working at this new game call to ready. Okay. That's whoops. So here. New game. Let's also assign main to our main scene, the one that runs automatically when the game launches. Press the play button. Let me not see sin when prompted. Okay. Select the current one. Save. Ah. No! It's all over! Where now? These are fucking massive. Hell yeah. Awesome. No. All right. Let's see. What's next? Yeah, the process says me too. You should be able to move the player around, see mobs spawning, and see the player disappear when hit by a mob. When you're sure everything is working, with the call to new game from ready and replace it with pass. What's our game lacking? Some user interface. In the next lesson, we'll add a title screen and display the character's score. Okay. Pass. Head to display. The final piece of our game needs is a user interface UI. Display things like score, game over message, and a restart button. Create a new scene, click the other node button, and add a canvas layer node named HUD. HUD stands for heads up display, an informational display that appears as an overlay on top of the game view. The canvas layer node lets us draw our UI elements on a layer above the rest of the game, so that the information it displays isn't covered up by any game elements of the player or mobs. Okay. Start a new one. Here. Turn this off. No. Canvas. Canvas group? Oh, canvas layer. There we go. Glad I checked that first. The HUD needs to display the following information. Score changed by score timer, a message such as game over or get ready, a start button to begin the game. The basic node for UI elements is control. To create our UI, we'll need two types of control nodes, label and button. Create the following as children of the HUD node. Label, name, score label, label name message, button name start button, timer name message timer. Score